Okay, so if we take a look here, the goal of this is to be able to simplify polynomials by common factoring. Okay, so we're basically, what you're going to learn today, we did expansion. I'll give you more time to work on some expansion, but what we're going to do now is like do the opposite of expansion. So Aiden, you asked about multiplying the 12 in. What we're going to do now is take the 12 out. So you're going to be given a whole bunch of questions where you have to recognize, oh, there's a 12 in common across all three of these things. I'm going to take it out. It's the exact opposite. Does that make sense? That's what this is. This is what you want to do all the time if you can. Okay, you're going to try and simplify things by pulling out a big piece. That's what this is. Okay, common factoring. Okay, that's a gist. Any questions? So if you keep that in your head, okay, as you go through this, hopefully it'll like make more sense than if you didn't have that in your head. Okay, so here's the success criteria though. You're able to identify what's common across all the terms. Okay, so again, this is why we discussed what terms were. So you might have 3 terms. You're going to look at them individually and see, is there a 12 in all 3 of them that I can take out? Okay, and then you're going to remove what we call the greatest common factor. That's GCF. You'll come in to learn that, okay, by dividing all the terms by the GCF by breaking common factors into both numbers and variables for easier identification. Okay, lots of words there. And then you're just going to rewrite the polynomial with the greatest common factor removed. Okay, so just how the questions look before you multiply the 12 in. Okay, you're just doing the exact opposite what we just did in lesson 1. That's all. Okay, so factoring is the opposite of expanding. I've said that like 3 times now. Okay. Factoring means to express, okay, as a product. So you're multiplying. Remember we said the word product was multiplying. I'm just adding multiplying. You don't have to. I can't even fit it. Okay, it is the opposite of expanding or multiplying numbers in. Okay, so here I've done 2 equations here. Okay, the top arrow is what I just showed you in lesson 1, where you would multiply the 4x in. That's what we're going to call expansion. Okay, what we're going to do now is what we're going to call, we're going in the opposite direction. Okay, same idea down here. Doesn't matter how complicated it gets. If you multiply, that's what we're calling expanding. Okay, additionally, I'll add this too. If you expand, let's just say you're generally multiplying. I think you're just always going to multiply. I can't think off the top of my head where like expansion wouldn't be multiplying. It doesn't make sense. Okay, factoring in your head, if it's the opposite of expanding and multiplying, then it must be what order of operation? Division. Okay. Basically, when we come down here, I'm just going to fill this out again. We're going to skip a whole bunch of lines here. Okay. We will fill them out as we go through the lessons. Okay. Basically, you could number these lessons. Right? This is what we're doing today, or on this one. Okay, after lunch this will be lesson 2. We'll fill it out. I don't want to make you write it all and like it doesn't mean anything. We'll slowly build it. But 1, 2, 3, 4, ABC, like working from here down, is the order in which you want to try to do these questions in. And you're going to go in your head, okay, I'm going to try and do number 1. I can't. I'm going to try and do number 2. I can't. Number 3 works. Okay. You don't want to do number 5 if you can do number 3, basically, is the gist. Okay. They get progressively harder as you go down the page. That's all. Is that okay? Okay, so we can skip those lines. We'll fill them out later as we go through the lessons, okay? But that's what we're doing today is common factoring in this lesson here. Okay? So we are after what's called this greatest common factor, okay? That's what's going to be in step 1. You're going to determine the greatest okay, that's what we denote as GCF. If you see that all over the place, okay? So with the first one, you're going to look at both terms. Remember, a term is, one term would be the 25x to the power of 5, and the second term would be negative 40x cubed. You're going to look at them both as a polynomial or a package, right? And you're going to look at what's common between both of them. Does that make sense? So it's buried in there, but there is something common amongst both of them. And keep in mind, just like terms, not like terms, but when we talked about terms, terms are made up of coefficients and variables. Two separate things, okay? And signs, I suppose. So when you're looking at this, look at it from the perspective of I have numbers. So you're going to look at what's common amongst the numbers. That's kind of an easy one, right? Where you're like, okay, well, 25 doesn't go into 40, but 5 would go into both, right? So that's the first piece of your common factor. You've got the number piece taken care of, right? So I could say, I'll do it in green to the match. 5's in common, right? So for you, if you were to divide both of these things by 5, you're going to get something on the inside. It's going to be 5 minus 8. Okay, I left spaces there on purpose because now we have to deal with the variables, okay? Can everybody see if I multiplied the 5 back in and then into the 8, I'm going to get 25 and 40? Okay? I'm just leaving spaces on purpose because that's only half of what we have to do. We still have to look at the variables, right? Because terms are made up of numbers and variables. Okay? So let's take a look at what's common amongst the yellow stuff. I can't write in yellow, but I'll write in black, okay? What could I divide both of these things by without causing issues, I suppose is the question. Retta.
X cubed.
Okay, why did you select x cubed?
Because it's the greatest common factor.
Okay, without using all that terminology, that's brand new. That's like defining a word and using the word in the definition.
I don't know. You divide x cubed by cubed and x.
Yeah.
X to the power of 5 by x or x cubed.
Okay, you could look at it as being okay. You're looking at these two pieces. I don't know. I'm completely thinking off the top of my head here. As like two people, right? And you're a thief, right? You want to steal from both of them, but you can only take as much as the poorest person. I don't know, I'm completely making something up here. Okay? So by that I mean you have x cubed, that's the smallest thing. You can only take x cubed from both people. Does that make sense? So if I were to divide by x cubed, okay, I could take x cubed out. And then your question is, what's left after I've taken the x cubed out? Well, on this side, there's nothing because x cubed divided by x cubed is just 1. Right? That's why you've done it. But on the left piece, you had 5 x's and you took 3 of them away. X squared. Okay, so basically your final answer, just to clean it up, would look something like this. Was that clear enough? I completely made that analogy up off the top of my head. I don't know if it's really that good. Okay. The idea is, remember what's going on here. If I look at the dynamics of what's going on, can I zoom out? Are we okay? If I go back up here and look at the arrows, to expand is one direction, factor is the other. Okay, so what must be true if I'm right? This is like an easier way to check than lines, right? Remember you plug the point in for lines to see if you were right or wrong? This is even easier. Because if I go like this, I take this piece and I multiply it back in here. Can you guys see the yellow? Yeah. You should get the original one back, right? Does that make sense? If you've done it right. Because these are opposite processes. You have to get the original back. That's how you know if you're right or wrong. Okay? The rest, the other two things underneath there are just the steps for which you to do them in, okay? You're just providing words to what I just drew on the page there. Is that okay? So we can do some more examples. Honestly, with all this stuff, the more you do, I think some of you saw it with the word problems yesterday. By the time you got halfway down the page with the word problems, they set up the exact same way every single time. The certain styles, right? There might be a couple of weird questions where you have to solve for something else, but it doesn't change the way that they set up. It's the same thing with this. Okay? The more of these you do, the easier it becomes, okay? All right, let's take a look here. We'll start with something easy, okay, and we'll work through. So, I would first look at, what do you think is common amongst the numbers? Let's take that out first. They're both multiples of 4, but sometimes you want to look at the relationship between the two numbers themselves. Like that could be, like 4 in this case goes into 16, right? Does that make sense? Yeah, I know. Sometimes you can just look at the two numbers and see. Like sometimes you might have two numbers that, like in the last question, you couldn't take 25 out of 40, but there was a 5 embedded in there. That's what I mean, right? So with this, I see that I can find a factor of 4. So you're basically, what I would like to see, just for the first little bit, before, like I'm trying to scaffold it. Does everybody know what scaffolding is? The stuff on the outside of buildings, when they're like building buildings. That's kind of like a teaching term that we use, like we build you from the ground up, okay? So like this would be kind of a ground floor tactic for you, okay? Just to identify the greatest common factor first. So we said there was a 4 in common, okay? That's to deal with the numbers. Now the variables we're after next, right? What is the biggest variable you could pull out from this thing? Remember, you're trying to steal from both of them, but you can only take as much as the one that has the least. Does that make sense? So for this, I only see 1x over here, which means I can only take 1x out. That's your greatest common factor. Okay, once you have that, you can think of it like expanding, but you're kind of backtracking, right? So you're going to write 4x, but then you have to fill in the inside of the bracket, and essentially what it is you're doing, once you identify this greatest common factor of being 4x, you're basically doing what we said earlier, you're dividing. you're dividing each term by 4x. The result of doing that goes inside the bracket. So now your only question is, what's 16x cubed divided by 4x? Well, 16 divided by 4 is going to be 4, okay? And then you're looking at x cubed divided by x. Well, one of these just cancels with one of those and becomes a squared. And the second one's really easy because it's 4x divided by 4x. That's 1. And you just bring the sign that was in between the two down. You could confirm that's right by expanding again. What's that? Is that okay? So, let's do the next one. Always start by identifying what the GCF could be. Okay. So for this one, you're looking, I always start with the numbers, and I'm like, okay, what's the biggest number I could pull out of all of those? 4 doesn't go into 6, it doesn't go into 18. I'm going to say 2. 2 goes into all of them though, right? Okay, that's good. What's the smallest variable you can pull out of all 3 of them? I see 4 of them here. I see 2 here, and I see 1 there. You're looking for the smallest. Just x. Okay? So, then you just rewrite the thing. It's 2x. You open a bracket, and you tell me what's left after you remove the 2x. If that means some of you are going to be able to do it without the division part at first. The goal is maybe you guys can get to the stage without having to do this every time. Okay, now you're just going to do these individually and then write them inside the bracket, right? So it's going to be 6x to the power of 4 divided by 2x. Deal with the numbers first. 6 divided by 2 is going to be 3. The x cancels with one of the x's up there. Now you're left with a 3, so it's x cubed. Move on to the next one. Negative 18 divided by 2 is going to be negative 9. X cancels with one of the x's up top. You got an x left. And then in the last one, 4 divided by 2 is 2. And the x's cancel. And you're all done. Okay? We just keep kicking up the intensity, that's all. But all you're doing is looking at all the terms, what's common across all the terms, that's all. Doesn't matter if there's 2 variables, 3 variables, 4 variables, and 2 numbers. Like 2 numbers would be just multiplied together, but that's it. You're just looking for what's common. Let's do the next one. The GCF here. Okay. 15 obviously doesn't go into 27. 3 goes into itself. It goes into 15 and it goes into 27. So let's just take the 3 out. Then you're looking at the other 2 terms. Okay, well, or the rest of the terms in terms of the variables. Well, I got 2 variables in this question. That's the trick, right? That's fine. You're just going to treat them separately, right? You're just going to look at, okay, well, person 1, 2, and 3 has differing amounts of apples and oranges. But you're going to have to steal an equal amount from all 3 people. So you got to go find, okay, well, what can I take out of all 3 of these baskets, if you will, right? Separately. Well, let's deal with the x first. Okay. I see two x's here, I see an x there, and I see an x there. So I can take one x away from all three of them, right? And then I'm like, okay, well, how many oranges do each of them have? Well, this has got 3, 2, 1. Okay, so I can only take one. Okay, so then you write it, 3xy, open the brackets, and fill in the bracket. Okay, so all you're doing again is dividing by 3xy. All three terms. Okay, so in the first one, 3 divided by 3 is going to be, or negative 3 divided by 3 is going to be negative 1. And x cancels with an x up there, right? So you're going to get just x left. And then a y cancels with one of the y's, you're going to get a 2, so y squared. That's fine. Move on to the next term. 15xy divided by 3xy. Okay, plus 5. And x cancels with the x. Okay, the x is gone. 1y cancels with one of the y's up here. So you're left with just a y in this one. And then the last one, shouldn't write plus. You're going to do negative 27 divided by 3, which will be negative 9. Right? X's cancel with the x in the top, and the y cancels with the y. So that's it. You're done. Don't forget your equal signs. I'm bad at that. Okay. These are all equal statements as you go down your page, right? So you got to write equals. Yeah. Yeah. Because you could, in theory, basically what's happened, if you remember from lines, like let's just use the first one as an example because it's really easy. You have 16x cubed minus 4x equals 0. What could have been here was 16x cubed is equal to 4x or something. Just implies that something's been moved over is all. Okay. Is everybody okay? Is the stealing method kind of starting to work its the lingo out? I think it's doing an okay job. It's tough to read the room with half your face is covered. Can't always tell. Okay. Okay, again, it doesn't matter how hard these things get. Right? I'll do D and then I'll do like F or G or something, okay? Yeah, and I'll give you some worksheets. Oh, I'll post the solutions too so you guys have them. I just want to give you some more work time, that's all. Okay? So I'll do D and then I'll post the solutions. You guys can copy them if you're stuck or something, right? Okay? But D looks like a doozy, okay? So let's take a look at it. Separate from me, okay? So let's write the GCF. Okay? Look at them all individually. What do we got? Well, we got numbers, so let's deal with the numbers. It looks like 20 can go into all of them. Okay, so let's that's the first piece, 20. Okay, so now we're taking care of the numbers, okay? Next thing I see is an A. What's the biggest number of, let's call them apples, that I can take from all 4 people? All 4 terms? 2. That's from the second one. The second person only has 2 apples, right? So I'm going to take the 2 from all 4. Then I'm looking at the B. How many B's can I take away from all 4 people? 3. So B cubed. Now, next step is just to write 20A squared B cubed. Open up the brackets and tell me what's left on the inside, okay? So something that looks really big, it follows the exact same rules. You just have, it's really not any more difficult. Right? So let's look at the first one. Let me move some stuff here so we can actually do the division. Okay. $40a cubed b to the power of 6 divided by 20a squared b cubed Okay, so we got that. Now you just do the division. This is filling in the brackets, right? So 20 divided by 40, or sorry, 40 divided by 20 is going to be 2. 2 a's in the bottom cancel with 2 a's in the top. That leaves just 1. 3 b's in the bottom cancel with 3 b's in the top. That leaves 3. You keep going. Negative 20 divided by 20 is going to be minus 1. 2 a's cancel with 2 a's. 3 b's cancel with 3 b's. That's a nice one. Let's go to the next one. 60 divided by 20 is going to be 30. 3. You guys are ahead, eh? 2 a's cancel with 5, or 2 in the top, leaves you 3. 3 b's cancel with 3 b's in the top, leaves you with 1. And then negative 80 divided by 20, 4. 2 a's cancel with 2 a's, leaves you with 2. 3 b's cancel with 3 b's. You're done. Okay? We'll do one more, because this sets up the lesson for this afternoon, okay? We have till 11:05. Yeah, last period. No, it'll be the word problems.
Oh.
Are we gonna do more of this today?
Yeah, I'll give you less time today. As soon as you get, honestly, it's like, I don't know where it is. It's almost like one page, the quiz. So you should finish it half a period maximum, and then you'll have the other half to work with Mr. Lin on whatever you want. Okay? Is that good?
Not last period.
Last period. We switched today. Okay, so we'll do one more lesson today, and then you guys have all weekend to study and do more questions and stuff like that, okay? What I'll try to do is somehow get your quizzes back to you maybe like before Monday, so that you can fix whatever's wrong for the test Monday afternoon. Yeah.
Did you mark the quiz that we did yesterday?
The test?
Yeah.
The test is done with the exception of 3 people. I'll mark that and hand it back in last period today. I was tired and I just stopped. I had 3 left, I just stopped. So I'll do this tomorrow. Because I knew you guys are going to be writing a quiz class. I'll get it back to you before you leave today. Okay. Good. Let's do one more. Okay. This one here, F will set up this afternoon. Okay. So, and I'll post solutions to the lesson too. Okay, so you guys can, if you need E and F. Oh, I guess there's 2 F's here. Okay, you need the rest of these questions. Okay. Now, this one's a little bit different, and this can take a little bit of a flicking of a switch in your mind to get your head around this.
Which one are we doing?
F, second F,
That's the tricky one.
the tricky one. If you want it, we can do those. It doesn't matter. I just want to give you time to work. I'll post solutions. Okay. The second F we'll look at, the tricky ones. Okay? Because that's what's setting up this afternoon. Okay? Now, the principle does not change, right? We still have 3 terms here. What do you see as common amongst all 3 of those terms? Coco?
We always like W plus 1.
W plus 1 is on all three of them. Okay, so that's your greatest common factor. It's whatever's common amongst all the number of terms. That's your greatest common factor. In this case, it's W plus 1. Okay? After you've identified that, all you have to do is divide everything by W plus 1. And remember to write the greatest common factor out front. Okay? So what's left? W plus 1 cancels with W plus 1. What's left? 4x plus 5y minus 3.
I have a question though.
Yep.
Does like like the W plus 1, is that 1 kind of plus the -3 coefficient because it doesn't have anything else?
-3 coefficient. Say that. Are you talking about right here? This one?
Yeah, like if it's like -3 divided by, is that part being divided too?
Yeah, but remember, it's not really a great.
Stay the same.
Yeah, you're just. Remember, these are all like just individual pieces, right? So you're able to just. It's no different than a number. Like if I told you that W equaled 1, right? If W equaled 1 and you had 1 plus 1, 1 plus 1, 1 plus 1, 1 plus 1, you'd have a whole bunch of 2's here that would cancel. You know what I'm saying? Same thing. I just haven't told you what W is. It's just a piece that you're removing is all. Does that make sense? Okay, that's your answer. That's it. Okay, that sets up this afternoon actually pretty well, which we will use in a more complicated situation. Okay, so it's important to know that one, just so you've seen it. Okay, there you go. I even specified the questions to do on this one. Okay. Is everybody good? Any questions? Okay. If you go into D2L, or Mine's Online, you guys never saw Unit 2, but the next unit that's populated now is 3.1. So all the stuff's starting to just pile underneath Unit 1 there, okay, and 1.5. So you shouldn't see any weird stuff like what I see. It should just be whatever we work on every day, okay? Okay, it's all there.